So, some quick reminders before we move on to the next part of the AC theory topic. Series circuits. In a series circuit, the same current flows through each part of the circuit. So if this is 1 amp, then there's 1 amp through this resistor, there's 1 amp there, 1 amp through this resistor, 1 amp there, 1 amp there, and 1 amp there. So the same current flows through all parts. That's important because we're going to need that later. In a parallel circuit, let's assume for the sake of argument we've got a 12 volt supply. Here we go. We have 3 components. In a parallel circuit, the same potential difference appears across every component. This is important because it determines how we start our phasor diagrams. Fortunately, in the first phase of the work that we're about to start, we're looking at series circuits, so we need to remember current first. So, quickly moving on, some quick recaps of what we've said so far. On a resistor and an AC circuit, then for the phasor diagram, we will draw the current first. There's the current. And in a resistor, voltage and current are in phase. So the voltage is on the same line as the current. And yes, this is rotating that way. On an inductor, let's draw the current first. There we go, that'll do. So there's the current that goes through an inductor, and in an inductor, current lags voltage. So here's the current, and that means our voltage across the inductor is going to be there. So it might take you a few seconds just to think about this one. I've just turned it 90 degrees from how we'd drawn it in the first handout. In the next part of our work, we're going to bring these two together, and we're going to consider a resistor and an inductor in the same circuit. So the current will be the first thing that we'll draw. There's the current, which will be the same through both of them. We're then going to do the voltage across the resistor. And then we're going to do the voltage across the inductor. Hopefully tidier than that. And the whole aim here is for us to produce a resultant phasor. And you can hopefully see that out of this, we can develop this into a triangle. So there's those two, VR, VL, and this, which will be our supply voltage, is actually the third side of the triangle. And that ties into much of the work that we'd done earlier on Pythagoras' theorem and some of the work on trigonometry.